That's strange. Okay, I hope it works. I hope you can hear me. That's the sound from the webcam, I think. Okay. Okay. Perfect. Thank you. Yeah. Welcome to the stream. I was a little before the time I scheduled. I wanted to try something, so yeah. Here we have M57 again, Ring Nebula. That's the first target for today, so I collimated the telescope. Maybe I can show you which telescope. That's the same actually from yesterday. That's a Skywatcher Explorer 200 PDS standing there. And I have connected my ZWO Asi 385MC color camera. It's a planetary camera. And here are some specs for the camera. So it has a quite low noise and high frame rate. That's really quite good for planetary stuff, but it's using the 385 IMX sensor, and there's already a new version, the 585, and spoiler, most probably today or tonight I will try a different camera, a new one with a 585 sensor from player one, and yeah, maybe later I will try it. And I will also use this Barlow lens later for Saturn, the 2.25 volt beta Barlow lens. It's quite cheap and it's excellent for beginners, I would say. And yeah, so let's go back here. So at the moment we are in this direction here, close to Vega, M57. That's here in the constellation of Lara. And here we have it. Here's the Ring Nebula. That's really nice. Yeah, and that's drifting because that's live here. We also can see the small, well, we cannot see it now, it's a small galaxy here. If we switch this on, you can see here it's a small galaxy, and that's M57, the Ring Nebula. Okay, let's turn this off, because I think my computer is already crying. Let's turn this off again. Yeah, so we are in this location. Later I will focus on Vega most probably, or another star. Let's see. And here is Saturn. Ooh. Here. As you can see, it's quite low. Still quite low here. Yeah, I think that's the first thing I will do. I will now try to refocus. Now Vega is very bright. Maybe we can use this star here. Just select it and then go to framing. I had the same problem before. I think I have to restart N.I.N.A. Let's do this. Okay. I just updated N.I.N.A, so most probably that's why, hopefully. All right, so now let's reconnect the camera. Okay, that's working, that's really good. Let's reconnect the focuser. That's also very good, it's working. And let's reconnect the mount, that's also working. So far so good. Then let's go to framing. Okay, now we can maybe see this. Pick this coordinate from the planetarium. Oh, now it's working. Because there was a big problem before. Because it was loading, but nothing was happening. So now it's working. Okay, that's nice. But I think that's not the star I want to have here. Just look at the ring. Cat's Eye Nebula with my Skywatcher. Wow. From a bottle form. Both were really easily visible. Wow. We can try this later. Yeah, that's a good idea. I will write it down. So, Cat's Eye Nebula. Amazing, great. Cat's Eye Nebula. We will try this later. Excellent. Really nice. Okay, now let's try again. Actually, I want to have this star. Pick the coordinates. Loading. Yes, nice. That's what I wanted to do. Okay, let's slew to the target. It's very close to M57, so what we did previously. And here we have it. Okay, let's wait a few seconds here. Yeah, exactly, Ring Nebula. Just a few minutes ago. I can show you what I got. Most probably. Where is it? Just a second. Yeah, here we have it. M57. Yeah, here. That's from yesterday, but it was same today. And I tried live stacking and SharpCap, which I didn't use previously. Okay. I will just go outside and try to focus. Okay, just a second. Okay. Okay, I just focused using this button of mask, and it will create a diffraction pattern, as you just saw, and that's actually perfect focus so far. And button off is already wet. That's the second night in a row doing astrophotography, and that's amazing. I don't know when I was able to do it last time, 2 or 3 days in a row, so that's amazing. Yeah, the only problem here, the sound is very low. Okay, thanks. Maybe I can change that. Properties. No. Is it better now? Can you give a feedback, please? Hello? No. Is it better now? Okay. But now you can see the problem here with this scope. So, as I said before, I'm using the 200 PDS telescope with 1000 millimeter focal length and the 385 MC planetary camera. And yeah, so most probably it's some kind of reflection, internal reflection, I think. I already have an idea how to solve this. There will be an extra video, I guess. So, but never mind, we are in focus now. That's nice. I will try to speak a little louder. Hope you can hear me. Okay. Yeah. So now we are here in the constellation of Lyra. Here, Lyra, Vega. That's M57 Ring Nebula. Okay. And we now focused here on this star. Yeah, let's try and redo the Ring Nebula. So I already selected it. Now you go to framing, collect the coordinates from the planetarium. In this case, it's stellarium. We have to wait a few seconds, I think. Yeah. But yeah, something is strange today. I have to do it 2 times. Okay. That's actually not... it's still the star. Okay. Okay. I'm so stupid. I know the problem, because I have 2 screens here. One is Stellarium on my Mac, and I'm remotely connected to my Chrome. Remotely connected via Chrome to my computer, whereas also my telescope connected and so on. And here I have to go to this, select the Ring Nebula, go back, pick the coordinates, of course. And this time it should work. La. Okay, that is really strange today. Here I have the square and here's the Ring Nebula. That's really strange. Let's try again. Okay, something strange. Okay, I will try to center and let's see what it's doing. Will it center on the Ring Nebula or will it center on something else? Wow, we have 4 viewers, live viewers here, great. Hello, welcome back to the channel. Welcome to the live stream here. So the big question is, will it focus or will it center on M57? or not? I think the answer is or not. Okay. Did I do something wrong here? Mm-hmm. It's already, it's written here, Ring Nebula, and all the coordinates here. But it's still not possible. Almost. That's really strange today. Let's try it like this. Center. Close. Mm-hmm. Oh yeah, finally we have it. Something is really strange today. So previously I did exactly the same, and then I pressed here, or I clicked here, and then there was just waiting symbol. Nothing was happening, nothing. And then here on top, and in the N.I.N.A screen, there was information about the update or something, and I just clicked it by accident. And then I updated it completely, and then it worked one time, and then I reopened or restarted N.I.N.A, and then it worked, and now it's just working at the second time. So okay, I don't know, but never mind. Now we have the Ring Nebula. That's very nice, and we have it in focus. That's nice as well. I'm doing 1 second here. Maybe let's try 5 seconds. So I'm not using a guiding setup tonight because I have my planetary camera and I have my 200 PDS telescope with 1000 millimeter focal length on the HEQ5-Pro, Skywatcher HEQ5-Pro mount, and the mount is screaming because it's just too heavy. This big telescope is on top of a HEQ5-Pro mount. That's actually too heavy. Okay, let's try 5 seconds. Let's try 3 seconds and increase the gain to 300. That's a planetary camera, so it's quite a high gain you need. Nice. Let's save some of the images here. You can even see the core star or center nucleus, center star. That's really cool. Wow, we have 5 viewers here. That's amazing. Welcome. Hope you can hear me okay now. I was just experimenting with the technical sides of a live stream here, but now it's running, I think. Okay. Maybe let's close this. Let's reopen SharpCap. I think I will. Oh no! First, I just tested it. You have to disconnect the camera because otherwise you will have some issues here. Connecting camera and SharpCap, then you will select the camera. It's this one. Okay, 3 seconds. You can see the Ring Nebula, and now we can do some live stacking. Here, live stack. Okay. Since I'm not guiding, the Ring Nebula is drifting downwards to the right bottom corner from center. So I just tried it this evening, and then you will have a weird looking edge, especially on the right side and on the at the lower bottom side. Let's try. Can we? Yeah. Let's remove or reduce the noise. We can see now. And here, if you go to status, you have no warning, so that's really stacking. We have a frame count of 20 now, so 1 minute. 1 minute of stacking. Ring Nebula, M57. That's amazing. Yeah, and since I'm not guiding, I will leave it at 3 seconds this time, I think. We can just try, save. Let's go here. That's 29 seconds without stretching, so that's why it's actually really nice. You can only see the shell here. I will call it shell. That's actually really nice. I like this. It somehow looks like an old image of M57 from Isaac Roberts. Do you know Isaac Roberts? Isaac Roberts, a pioneer in astrophotography, and he also he had a observatory, and he not just had observatory, but he also was able to track or counteract the rotation of the Earth, what we are still using, called a mount, telescope mount, so counteracting rotation of the Earth. And he was able to really get amazing images, amazing. I will just show you. Can I? Here, I can search it here. Let's do it like this. Maybe that's easier here. So that's M31 Andromeda Galaxy captured by Isaac Roberts. And the special thing is, this one was captured in 19th century, so it's from 1893, I guess. That's really amazing. But coming back to the Ring Nebula, there was also at least one from Isaac Roberts. Roberts M57. Roberts. Where is it? Roberts. Yep, here. No. That's also an old one from 1890. William E. Wilson, and this image is from 1894. Here. That's from 1894. Ring Nebula. Isn't this amazing? I mean, the normal photography was just invented. That's really cool. You can even see the core or central star, let's say. And yeah, let's look for M57 from Isaac Roberts. There was something. This one. Here. So this is today from stacking maybe 3 minutes, M57, and not even stretched. And this is from Isaac Roberts from the 19th century. I think it's just amazing because, as I said, normal photography was just invented a few let's say a few years ago or something. So really cool. Is it still working here? I think we are still connected. That's amazing. Six viewers. Wow. Thank you. That's amazing. Sound. What about the sound now? Is it better? Wow. Really cool. Wow. Amazing. Let's look. Wow. And you can already see the artifact here. That's from the drifting M57. And now we have 6.5 minutes of stacking, live stacking. 131 frames. Now you can get an idea about the central star, and this is not even stretched yet. Wow, really cool. Okay, I just will finish this. Pause. Live stack. Processed. Now it's processed. 147 frames, and this is stretched now. Yeah, you can get an idea about the different the shells, central star. Pretty nice. Let's close this here for a second, and let's reconnect the camera here. N.I.N.A. Okay, nice. Now let's try a different target here. I was really interested And this one here, M92. It's a cluster, or maybe the other one. Actually, it doesn't matter, right? Let's try M92. Let's see what we will accomplish here. Let's go to framing. Pick the coordinates from the planetarium. Software, it's Stellarium in this case. Yeah, almost there, almost. I don't know what it is today. Pretty nice. That's slew and center. I will just check my telescope. Pretty low. Pretty low. But we are still in focus. And here's a cluster. Nice. Okay, let's close this. Close. Yep. Okay. Maybe let's try 2 seconds. Here we have it. Nice. Beautiful cluster. M92. That's M92. Really nice. Wow. Okay, let's also try to do some live stacking here. Again, I will disconnect the camera. Otherwise, I will get problems with SharpCap. SharpCap. Let's select the camera. This one. 3 seconds. Yeah, let's do 3 seconds. Let's do a live stack. Wow. And it's stacking. 6 frames, 7 frames, 21 seconds. Total integration time, total stacking, live stacking time. Actually quite nice. Zoom. I have to admit, I'm not the SharpCap user. I used it maybe many years ago. Are we still in focus? Yeah, I think so. Oh. Is it still stacking? Resume. Ah, okay, now it's stacking. 24 frames. 1.5 minutes. Yeah, not. Yeah, almost. Okay. But. Wow. Yeah, maybe it's looking maybe not in focus because I stretched it so much. So here it looks really nice, and then if you increase this, of course, you blow the stars like in PixInsight. Yeah, let's leave it like this. By the way, if you did not join the live stream yesterday, just a second. I can show you something from yesterday. I can tease you with something we did yesterday. So yesterday we did the Pegasus cluster M57 Ring Nebula, and we also did Saturn. That's from, well, let's just a second. Yeah, we did Saturn yesterday. It was really low in the sky, as it is today. Here, let's remove the marking. Oh, my computer is really slow. Of course. So here's Saturn, and really low in the sky, and we have to look through huge amounts of atmosphere, and yeah, so that's why the conditions were not optimal. We had clear skies, almost no wind and so on, but it was really low in the sky, and I did several videos, and it was actually really nice. I did not process it so far, but here, that's from yesterday. If you are new to the to astrophotography, to the hobby and so on, you will recognize that it's wobbly, of course. That's the atmosphere, and it was very low, as I said before. So we have to look through a huge amount of atmosphere, so it's wobbling really, and you have temperature differences and so on. You have cold air, and you also have a sunny day, so you have high air turbulences or heavy air turbulences. And what you also can see is a color fringing here. Here you have a blue on the top, and you have some red here. And this is also due to the atmosphere, different diffractions of different wavelengths and so on. And you can compensate this by using something like this. That's an atmospheric dispersion corrector. So you have two prisms here inside, and you just use those adjusters here to shift the two prisms, and this is how you can counteract the color fringing. And we will most probably use it today. The only thing is, if you introduce this in your optical train, so on your telescope, let's say, you also have different focus point. So focal plane is shifting, and then you have to readjust your focus, and so most probably we will try it today with that one. Okay, but still I like it. I mean, it's really wobbly, and you have the color fringing. By the way, you don't have to use an atmospheric dispersion corrector, but that's actually, this will give you the best result, because you can really decrease this, and after that there's your camera. So you will record a video in this case, or a picture, or most probably a video, where you don't have the color fringing anymore. And if you do this in post-processing, so via processing, software processing, you can also reduce it to a certain amount, but will not give you the best results. So this is the better solution here, to use the atmospheric dispersion corrector. And this will not just reduce or even remove the color fringing, but will also increase the sharpness of your image or object, let's say. Yeah, that's from yesterday. Okay, but let's see how our live stacking is going. So we already have 7 minutes now. I also have something today for the live stream. Mars, of course. That's traditional food. I have no Milky Way today, but maybe next time. Yeah, I'm really hungry. Sorry, but I have to get some sugar. Well. Okay, so we are almost 8 minutes in live stacking of the beautiful M92 cluster. Does it have a name? That one, right? No. M92 or NGC 6341. I think I will stop it at 10 minutes or something. We still have 3 viewers here. That's amazing. Thank you, by the way, for joining this live stream. Hope you enjoyed. If you have any questions, please write down on the chat to have more interaction, to have an exchange, and maybe you have some questions, maybe you want to say something nice. Yeah. I really really hope the sound is okay. Hmm. 9.5 minutes. I think after that I will try to center on Saturn. Almost 10 minutes. Now we have 10 minutes. Let's save. Let's stop the live staging. And let's see. That's processed. 202 frames. No, quite nice. Really nice. Oh. Okay. Let's close SharpCap. Let's reconnect the camera. Now let's go to Stellarium. I think, by the way, there was a hint from 3DFX Voodoo Cards. That's an excellent name, I really love it. That remembers me of so much from my childhood. Video games and so on, I really loved them. And most of the time I had no money to buy such an expensive graphics card. And once, yeah, at one time I had a 3DFX Voodoo card and it was amazing. It was really amazing. What did I want? Okay. Okay, I remember what I wanted to do. Cat's Eye Nebula. I have to search this. Cat's Eye. The catalog number. Yeah, that's nice. That's really nice. That's NGC 6543. But where is it actually? Cat's Eye Nebula. No, not Galaxy. Cat's Eye Nebula. Wow. Yeah, I remember this. Okay, that's nice. Yeah. I think 3DFX in the chat. We will try this. Most probably we can only see the core because I'm using a planetary camera today. But we can try this, of course. I think it's still in the, yeah, it's still in the range. It's possible to get it. Yeah, let's try. Too slow. Cat's Eye Nebula. Let's go to framing, pick the coordinates from Stellarium. But that's really, Cat's Eye Nebula is one of the targets I also wanted to image for a long time. Wow. Sunflower Nebula, okay. Let's slew and center. Ooh. I just have to check my telescope. Okay, I'm back. So still standing, telescope is still standing, almost no wind. Yesterday was really crazy. There was the humidity in the air was so high that it was really soaking wet when I removed it from the balcony, which is standing there. It was really great. Okay, don't talk anymore. Let's try this. Cat's Eye Nebula. Most probably that's it. That's a core. That's a bright core. Cat's Eye Nebula. Yeah, that's the core of this nebula. It's really bright. Wow, that's amazing. That's amazing. Since it did not look really sharp, the cluster M92 cluster, I will try to focus, to check the focus again. Just a second. The problem is I don't have a bright star in this location, but looks quite quite good, I think. 6 seconds. Let's center, recenter, and then we will do a live stacking. I think that will do. Let's disconnect the camera. Yep. Let's reopen SharpCap. Select the camera. This one. Let's try 6 seconds. Wow. Can already see it. I think it's too bright now. Yeah, it's really bright. Wow. It's really interesting. What's the magnitude here? 8.1. Wow. Let's try some live stacking. So that's the bright star most probably, and that's the Cat's Eye Nebula. Yeah, because that's a point source, and this is really elongated here. So I'm pretty sure that's a Cat's Eye Nebula, and that's the star. Maybe the exposure time is too high. Let's clear this. Let's try 1 second. Do a live stacking. Okay. Problem now is exposure time is too short. Cannot find any more stars here. Okay. Now let's do 2 seconds. Actually, really nice. Wow. You can even see some structures with 2 seconds exposure time. Let's decrease the gain. It's 400. Okay, that's even too high. 250. No, it's not working. Not working like this. course, it's milliseconds. Okay, 2 milliseconds. Okay, cannot do anything. I got it. Okay. Live stack. Here we have it. That's really interesting that you can already see the structure. Oh, get an idea about the structure here. Wow. And yeah, now it's doing something. No. Let's try 3 seconds. Yeah, not stacked. Resume. I think now it's working. Ah, okay. Wow, 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 wow. That's really cool. That's amazing 3D FX. Yeah, you can already see something. That was a really good idea. That's the very first time I tried this target. Wow, it's really cool. Burning flame, yeah. I'm using the 200 PDS. That's this one. This telescope. It has 200 millimeter, or I think it's let's try. Yeah, it's 8-inch telescope or 200 millimeter opening here, or aperture, let's say, and you have 1000 millimeter focal length. That's the one I'm using today. Yeah, and it's called Skywatcher Explorer 200 PDS. And actually it's too heavy for my poor little Skywatcher Explorer, Skywatcher HEQ5-Pro mount. That's actually too heavy for this mount, but for planetary stuff it's okay. It's working, but as soon as you have a little bit of wind, it's not working. And also I would not recommend to use it in this combination to do any deep sky astrophotography as we do now. Because it's it's a classic Newtonian, right? Exactly, it's a classic Newtonian. And I'm also using this camera here, ZWO Asi 385 MC refractor guy. Okay. Yeah, me too. Actually, I have a 90 millimeter Apo, and I really like it. Yeah, you also have this collimation thing and so on, and so I know what you mean. So I'm using this planetary camera, so it's not a deep sky camera, and here you have some specs. So it has quite a high frame rate, low noise, but it's still using the quite old sensor IMX385. There's already the 585, and later for Saturn I will also use this Barlow lens from Beta. It's 2.25 volt Beta Barlow lens. It's quite a cheap one, but it's doing its job and so on. Very nice. Yeah, that's a telescope I'm using. Now at the moment we are at the Cat's Eye Nebula. Really bright, at least on the core, and we do some live stacking now. We already have 3.5 minutes. It's the lack of sharpness, yeah, and contrast compared to refractors. Yeah. I mean, I don't know if it's a general thing. If you are right, I think there are also really excellent reflector telescopes and having really great sharpness and contrast and so on. But yeah, that's amazing. Which one do you have? Burning Flame? Which refractor? Can you recommend something? By the way, I have this TS Optics 90mm Apo. I can show you. I have this one as well. That's a 90mm 450 something millimeter focal length. Yeah, it's not a Takahashi, it's not high end, but it's doing its job. It's really nice, excellent quality, optical quality for the price. Of course, you have to pay, and yeah. But this is really interesting here. You can already see some structured core. Wow. We have now 5.5 minutes of stacking. Wow. Now I have a SV Bony. Ah, yeah. Wow. And the Bresser Achromat. Wow. No, it's excellent. It's really excellent. And do you like the SV Bony or the Bresser the most? I mean, compared to the two compared. Because Bresser, I know this model, but I actually have no idea about the optical quality and so on of a Bresser telescope. I never owned one. But no, actually that's not true. I had in the past there was one. Yeah, I had a Bresser. I think the SV Bony ones are really nice. I heard some good things about this, or about the refractors from SV Bony. It's really nice. Yeah, and really nice. Can get an idea about the structure here, central structure. I think that's one of the targets, like where you need a very low exposure time. Let's check this on AstroBin. Talking about AstroBin, did you see the today's AstroBin image of the day? That one? Wow, that's amazing. Did you already see this? That's from Henry Xu, and it's from today. I mean the image of the day today. That's amazing. You can see the shadow of the Earth, red moon, and that's just excellent. Wow, I love it, really love it. Okay, but coming back to the Cat's Eye Nebula. Cat's Nebula. I'm just interested to see how the people are doing this. Okay. Cannot find anything about exposure times for this object here. Nothing. No, nothing about exposure times. Wow. Wow. That's amazing here. I will show you. Okay, I found this image here, but this is actually this is from Telescopio Nazionale Galileo and Hubble core. So most probably that's from the core, that's from Hubble, and they somehow merged it with own telescope data from the shell, I guess. Wow, nice work. That's from Daniel Nobre. Hope I pronounce it correctly. Okay, nice. That's really an interesting target. The SV Boni is better, yeah, than the Bresso, yeah. Okay. Optical, the SV Boni has a lot less chromatic aberration. Okay. That's also sharper. Okay. Good to know. Really interesting. Oh. Excellent. Okay, so since we already have 11 minutes now, let's save this. Let's go to process. And this is what we have now. Wow. For 11 minutes, it's actually quite nice. You can already see some structures here. Wow, great. I will definitely try this once again with my deep sky camera, the 2600 MC Pro. Wow, really nice. Okay, let's close this, reconnect the camera, and now most probably you already waited for it. We will go to Saturn. So here's the Cat's Eye Nebula. Let's go to Saturn. It's somewhere here. Here. Okay, let's Saturn. Okay, here we have Saturn. Most probably I will use a 2.25 volt Barlow lens. We have Titan, all the other ones, Atlas. Wow, so many moons. Yesterday was the same, it was like a chain here. All the moons, or not all, maybe many of them. Saturn. Okay. Let's go to framing. And that's really the good thing if you connected your planetarium software like Stellarium with N.I.N.A. So you cannot search for planets here, but if you use your Stellarium planetarium software, you can just import the coordinates and then you are almost there. Just a second, I will pause this. Now it's loading the coordinates. Still some Mars left. That's Slew and Central. Sorry. You want to know what's inside here? Keep watching. Wow, 3D FX. I just translated into English. So you only had 1 hour of clear skies, most probably today. And now you're waiting for the clouds to pass and then you want to take a look at Saturn. So doing exactly the same what I'm doing now, and maybe other people as well. Really cool. I hope it was center now, but I can see some bright thing there. Waiting. Of course, if you have such a high focal length, I mean, it's not super high, but it's 1000 millimeter. Without a Barlow at the moment, there are not so many stars to do plate solving. But yesterday it worked actually very well. Today there's something with the framing assistance. Something is it's not nice. There's something. What to do now? Let's try again to get the coordinates. Okay. Let's try again slew and center. Yeah, you 3DFX voodoo cuts, you saw 5 moons easily. Yeah, was the same for me yesterday. At least 5. Oh, there's Saturn. Now it worked. And here you can see the problem. Yeah, so burning flame, I feel you with the refractors and so on. Most of the time you don't have such a big problem, optical problem with the refractors. I have to readjust something. I have no problem to do collimation, although it was quite difficult today. I did something wrong, and then at one point the laser, I'm using a laser for collimation, it was out, and I had to use my screwdriver and so on. So it was quite a long process today, but that's okay. But now as you can see, I have something with this reflector telescope. I think most probably that's internal reflection. I also have an idea how to solve this problem. Most probably there will be a video, but you can see as when you have a very bright object, you can see this strange pattern here. So it's not about collimation. It has nothing to do with the positioning of the camera or something, and I'm pretty sure it's not a real light leak. I think it's internal reflection or something, but never mind, that's Saturn. Okay. Now let's go to Firecapture. I know many of you are using SharpCap, but I'm always using Firecapture for planetary stuff. Always. So first first thing you do is most probably you go to maximum, and then you don't have so many problems to find the object you are looking for. Oh, sorry. Okay, and that's already Saturn here. Nice. I think I have to or want to rotate the camera. Yeah, I think that's the first thing I will do. Something strange here. Yeah, that's the first thing I will do now. What bottle zone do you live in? How is the light pollution there? I think in a bottle 5, I guess, 5 or 6. Suburban, I would call it, and yeah, it's actually okay. I mean, it's much better to where I lived before. It was almost inner city. It was downtown. Not really, but almost. And so today it's actually quite nice. Bottle 5, it's okay. Yeah. Now first thing I will rotate the camera and whole camera. Okay. I also had this yesterday. Here, there's something with USB cable. I hope it will work again. So first disconnect the camera, then go to Firecapture. Okay, now it's okay. That's one thing. That's really one strange thing. So I recognized when it's colder outside. From time to time, I have some problems with the connectivity to the camera, and then you get some error messages like this one. But now I just reconnected, and then it was working. The thing is, the original cable from the camera, I think, has something. Most probably it's broken. And then I bought a new cable, USB cable, and today I did a research about the cable and which cable I will need for this camera, and ChatGPT, I asked ChatGPT because I'm too lazy to do the research, and it's ChatGPT said you have to have a USB 3 cable, otherwise the USB 2 cable most probably cannot do the data transfer here, and from time to time it's stopping. I did not check it so far, but maybe it's not a USB 3 cable but a 2. And I already ordered one new cable, so yeah. But never mind. First thing I will rotate the camera. Yeah, it has some problems. Rotate the camera and then yeah, I think I will directly use the 2.254 Barlow lens. Here you already can see a moon. I can just increase the exposure. Yeah. Huh. Wow, so many moons here. So here's Saturn in the center. And what else do we have here? That's... Which one is it? No, stop it. Stop it. Yeah, I can see it's almost too much. The streaming, the video signal, and the remote control to the camera and so on, to my computer, it's almost too much. Do you know which moon this is? Can you see the Milky Way? Just looking at it from your place. Most of the time, no. I cannot see it. There was one night last year, it was excellent seeing and was perfect for this bottle region, and then there was a hint of Milky Way with a bare eye, but I also have to say that I was outside only for maybe 10 minutes because it was so cold. If you are longer outside, maybe half an hour, your eye will adapt, of course, and then yeah, I think it's possible in good nights, during good nights, and to see the Milky Way with your eyes from here, but that's very rare. here. I never was able to see the Milky Way from my location. 300,000 people sitting here. That's so sad. That's really so sad. I mean, so light polluted that you cannot see the Milky Way from most of the areas and so on. That's, yeah. Okay, but that's one topic for its own. So here we have Titan. I don't know which moon this is. Here it has. Then you have Iapetus. How to pronounce it in English? Iapetus. I don't know. Tethys, Dione. So Titan. This. Yeah. Okay, that's Titan. Definitely that's Titan. That's the moon I don't know, and it's not written there. This is most probably Iapetus, or how to call it. Yeah. Okay. I will decrease the exposure time here again. Now I will rotate the camera. Okay. And I will also insert the 2.25 Barlow Beta lens, Barlow 2.25 volt beta Barlow lens. This one. It's quite a cheap one, but it's doing its job. And yeah, of course, you can buy a Teleview PowerMate. I think it's twofold, the Teleview thing, but yeah, just a fraction of the price. And I don't have the money, or at the moment I don't want to pay the money for a Teleview PowerMate, although it's excellent, no question about this. Okay, I will use it, first I will use it without ADC, or will I use the ADC? Don't know yet. First let's center this. Let's center this. I have a control somewhere. Where is it? Here. No. Okay. Let's go outside. Yeah. So I rotated the camera, as you can see. I also used the 2.25 volt beta Barlow lens. I will never learn it, and I think I will also use this ADC now. Let's try. Of course, you can see it's really wobbly. It's just too low in the sky. I will try the ADC. Yeah. Okay. Very wobbly. But let's try something here. Maybe start with one minute. Yeah, maybe I have to readjust the ADC. So the blue and the red should overlap. Yeah. Maybe I have to adjust a little bit, but okay, let's try this. Frame rate is 147 frames per second. Nice. Okay, 3DFX asked the question how the 90mm Apple compares to my 200mm Skywatcher. So the Skywatcher I'm using now. So this one compared to this one, when I look at the planets, I have to say I never did the visual astronomy of planets using my Apple. Never did this before. So I cannot really say anything to that. The difference between the telescope is night and day. Opening, so aperture, of course you have more resolution. This I can really say, so that's amazing. You can see so much more when you have a higher aperture. I mean, so much more. I mean, resolution and so on. So when I compare my 200 PDS, so the telescope I'm using at the moment, versus my 127 Celestron Maxutov. Of course, it's different kind of telescopes, but you can really see that you can really say that you can see more details, more when having equal or almost equal focal length, and then compared 127 Maxutov telescope versus 200mm. That's a big difference, you can tell. So yeah, I mean it's made for completely different objects, right? Or so I do 2 minutes here. Yeah, it's completely different. So it's hard to tell. I really like the Apple for deep sky objects, and actually I'm only using my 200 PDS for the International Space Station and for planets and so on. I also did some projects, deep sky object projects with the 200 PDS, but yeah, as I showed you before, there's a problem, most probably internal reflection, and if you do long exposures, you can see it. Even if you don't have such a high gain, but high exposure times, you can see this, and most probably I have an idea how to solve this problem with internal reflections and so on. Now, we just had 10 viewers Wow. Simultaneously. I mean, somehow I'm not happy with the focus, and somehow I'm not really happy with the ADC. Maybe I can improve this. Yeah. I will go outside and check again. Okay. This rooftop or balcony is really like a seismograph. It's shaking and shaking. Okay. But now I think it... Yeah, it's much better. So, using an ADC, you have the two prisms. You can adjust it and so on to each other, and then therefore, or using this those prisms, you can reduce the color fringing, and if they overlap here, the red and the blue, it's better now. Most probably, yeah, I think it's also sharper. I did not change the focus, but really looks sharper now. Okay. Let's zoom in again. Let's change the ROI. Let's do a little bit smaller. So we can... So we can... oh, so we have higher frame rates. Let's try again, 2 minutes. And it's recording at 147 frames per second. Now, And in a second we will compare this. Saturn. And then we can compare it with ADC and without. That's 2.25-fold. No ADC. No. Let's start again. 2 minutes. No ADC. And this was with ADC. 2-fold with ADC. Okay, let's stop this. With ADC, okay. Okay, so this is no ADC. You can see the color fringing. So you have the blue here on top and you have the red here. And this is with ADC. Direct comparison, same camera. So here you have the color fringing. This is with ADC, really adjusted, very well adjusted. I think for me it's sharper here. I think I can see a band here. And you don't have the color fringing. It looks quite neutral, I would say. So left is without ADC, or with ADC but not corrected. And this is with ADC. Oh. Okay. Nice. Mhm. So let's see. I don't know. Compare the 90mm Apo versus 227 Mach. You think it should be better for planets, the Apo? Most probably, yeah, maybe the contrast, but the resolution for sure not. But yeah, the optical appearance, maybe that's what you mean. Chef, yeah. That here, now I can see it. Okay, it's sharper and higher contrast. Yeah, most probably using the Apo. Yeah, most probably you are right. I would agree. So Skywatcher 200mm Newton on a balcony. Yeah, yeah, it's on my balcony. It's right there. And it's shaking. Yeah. Okay. Um, yeah. One thing, two things left. So first I will again do capture a new video here. Saturn decrease. Now that's a little bit too small. 400 by 400. Yeah, or let's do 400 by 400. Oh, that's really small. Wow, okay. Let's try this, but I think I cannot get 2 minutes of this. Oh. Welcome to the live stream. If I did not already say hello to you all, nice to see you. Oh, you can see me. I cannot see you. Yeah. For 172, yeah, the frame rate is a little higher. 127, 172 versus 148, but it's too small for me. It's drifting, really drifting very fast out of the field of view. That's why I will increase I increased the field of view, or ROI, region of interest. Let's try again, 2 minutes capture. So 2 things left for this live stream. I think it's in Germany it's already 1 a.m. in the morning. Of course, now you know we have Oktoberfest, so that's why. Today I have something special here. I'm not such a big beer drinker, to be honest, but I like this one. It's called Spaten, or we call it Spaten, and Spaten is exactly this one. So this tool in Germany it's called Spaten, and yeah, that's Munich Light. Translation. Münchner Hell. And there's also an Oktoberfest, because we have Oktoberfest at the moment. So I'm not in Bavaria, but we have Oktoberfest in Germany at the moment. So that's why I thought maybe let's drink a beer tonight. And before I do this, I have to know what's Spaten in English. It's spade. Spade, right? Are you all English natives? Okay, that's spade, and I like this one a lot. Okay, and of course I will open this spade beer with the Guinness with the Guinness opener, and that's original from the Guinness brewery in Dublin. Or not from the brewery, I was there, but that's from, yeah, from a shop in Dublin, original. So, and here of course you have the so-called Kronkorken. I think in the US you don't have something like this, you just have a screw opening. So yeah, I like this. But before I have a drink, I will realign this here and do another video. Yeah, okay. Prost. Prost. Nom nom nom. Very good. I think what I will do, I will try to increase the focus here. I'm not sure if this is really the optimal position of the focus. I will just come back here. Just a second. The balcony is shaking like crazy, as you can see. So I was just outside and I changed the focus, and I really, now I have a better focus. I can see a band here. I don't know if you can see this via YouTube, but now I can see a band here, definitely, and it's better. That's better. We will, of course, we will do a direct comparison. In the video. Same region of interest. Yeah. And let's do 2 minutes again. Prost. burning flame. Maybe the turbulences are mostly generated by the heat radiated from the building you live in. Yeah, that's possible. Yeah, definitely. I thought the same. I agree. I think that's true. Yeah. 3D FX Voodoo Card says yes, it's better now. Yeah. Thank you. Thank you for comparing with me, and thanks for your feedback, of course. I have to finish because it's at the border here or at the edge. Okay, now I start again. 2 minutes. It's wobbling like crazy. But at least I can see a band now. So nice. And yeah, as I said before, with this region of interest, its frame rate is 147 at before. If you do so, that's 640, I guess. And when you lower it to 400 by 400, I think it was 170, maybe 180. It's really interesting. So there's not such a big difference. So if you are familiar with what we are doing, you know that this is lucky imaging. So you have turbulences and you're capturing a video. Maybe most probably you want to have a high, or you definitely want to have a high frame rate to capture really many single images within 1 second, let's say, and to really get only the best images. So that's called this is called lucky imaging. If you're new to the hobby, yeah, that's what we are doing here. I think now we will have a 2-minute video. So you want to have a high frame rate to capture the excellent or the best images in between, and you want to have many frames to stack. But due to the fast rotation speeds of the big planets, for example Jupiter, I think it's 9.5, 9.9 hours for one rotation. It's very fast, so you cannot, or you most probably you will not do unlimited videos with regard to the length of the video, because at a certain point you will see the rotation, and so then you use a program like WinJupus and you can derotate the images. But yeah. Okay, I will do one more video and then I will show you what's inside this package. That's most probably the last point of this live stream. Maybe 1 more hour. Let's see. So thank you very much to 3DFX, Voodoo Cards and Burning Flame and for contributing and giving so much comments and feedback and so on, and that's really awesome. Thank you very much. that's fun to get some kind of exchange here and to have a discussion or feedback and so on. That's really helpful. Thank you. I think I have to stop this. Yep. Yeah, one more thing. So that's a live unboxing, if you wish. It's a package from China. I received it several weeks ago. I did not open it so far, so I don't know if it's really what I wanted or want to expect or I expect. So, ta-da! Player 1 camera. That's a planetary camera, and this is the thing I want to do today as well. So I want to do a comparison. So this is a Player 1 Uranus C camera. As I said before, currently I'm using this 385 MC color camera, planetary camera with those specs, and it has this IMX385 sensor. And there's a new generation with the 585 IMX585 sensor with lower noise and higher frame rates. And of course, those frame rates are always connected to a certain region of interest. So if you're capturing a bigger area, of course, the frame rate drops down. And if you have a smaller area, the frame rate goes high. And this is the same here. And if you go and check the data, it has this camera, this newer one, I think it has a lower frame rate per second. But it's in relation to the region of interest. If you go to the same region of interest as this camera, with this camera, this one has a higher frame rate and lower noise and so on. And this one I want to test today as well as a comparison. So kind of a live unboxing here. Plastic, plastic, plastic. Color camera, Player 1 astronomy. Yep, IMX585. Made in China. Astronomical camera for solar, lunar and planetary imaging. Yeah, there's also a Apollo M, so a mono camera, Neptune and other ones. Just open it. Wow. And this is what you get. So here you have the camera, then you, what's that? Okay, blower. Air blower, that's quite nice. But I already have one. I like this one. It's in the shape of a rocket. Yeah, but that's actually very nice. Then you have different cables here. Then you have, I think you call it Allen tool. This one. Different cables. You even have a guiding cable. I think it's called ST4. And you have a USB cable. Oh. And of course, you have the camera itself. Wow. Uranus C. Nice. I really like the shape of the camera and the red from a big company, ZWO. No, I don't want to have any troubles with anyone. So for me, it looks like the color. It's a little bit darker, that's all. But yeah, and yeah, smells like, yeah. I don't want to say it, but it smells like. And here you have the sensor. Can you see it? Yeah. Wow. And the sensor is also bigger. I can tell. Yeah, it's definitely bigger. You have the connection ST4, yeah, and USB 3. And of course you have a USB 3 cable. Of course I will use this cable now to try the camera. How long is it? 2 meters? 3 meters? Wow, it's long. I think it's 2 meters long. Okay. So now I will go outside and change the camera, the ZWO Asi 385, this one, against this UN Player One Uranus C camera. See you in a second. Okay, this is working really nice. Not. As you saw, Firecapture is not able to connect to this camera, although I selected player 1 cameras. Maybe I have to check for the driver or update something or so. I don't know. That's why now I will, yeah, it's already late. I will end this stream now. Thank you very much for watching, and yeah, see you next time. Clear skies. Bye bye.